Hello, beautiful people. Today we're going to be talking about the quadratic formula. We're going to be using it to solve any quadratic equation. So we've done factoring, we've done solving by finding square roots, we've solved by finding completing the squares. Now we're going to use a quadratic formula which works every single time for any quadratic equation, any one of them. So many of you have seen this before, and some of you learned it with a song, x equals negative b plus or minus square root. I'm not going to keep singing because I don't want this to haunt me forever, but b squared minus 4ac all over 2a, where a is not equal to 0. If it was, then it wouldn't be quadratic. This is how we read it. X equals the opposite of b, or negative b, plus or minus the square root of b squared minus 4ac all over 2a. Okay, so there's your flashback, and today we're going to do some notes with this. So for our first example, we have x squared plus 9x plus 14 is equal to 0. Main thing with the quadratic formula that you have to remember is that one side has to equal 0. Everything has to be all on one side. Your variables and your constants all together on one side. So in order to find our solution, we're going to use this formula, and so we know that it is ax squared plus bx plus c equals 0. So for this example, your a is 1, your b is 9, and your c is 14. Here's what I know you can do. You can plug in 9 for b, 1 for a, and 14 for c, and then 1 down here as well for a. So do that. Go ahead and press pause, and you can check your answer with my answer. Okay, so hopefully you pressed pause. If you didn't, you're probably going to press pause right now to just copy down my work. But here's where I plugged in all of my values. Then I simplified order of operations. 9 squared is 81. 4 times 1 times 14 is 56. So 81 minus 56 all over 2 times 1, which is 2. Then negative 9 plus or minus the square root of 25 over 2. Square root of 25, perfect square. We love it. Negative 9 plus or minus 5 over 2. So from here, you're going to get two answers. One for when you add 5 and one for when you subtract 5. So negative 9 plus 5 over 2 and negative 9 minus 5 over 2. Two different ones, two solutions. So negative 9 plus 5 is negative 4 over 2, which is negative 2. And this is negative 14 over 2, which is negative 7. This is not a coordinate. These are two different values for x when we solve. That's it. And you can check your solutions by plugging them in here. So negative 2 squared is 4 minus 18, because 9 times negative 2, and then plus 14 equals 0. All right, your next example is this one right here. Some people like to move everything so that it's positive. You really don't have to. As long as you have one side is equal to 0, you are golden. So you can go right ahead here and label A, B, and C. So your A equals negative 1, B equals negative 2, and your C is equal to 5. Again, if you want to, you can pause. But otherwise, you're going to have negative B, so minus negative 2, plus or minus the square root of b squared is 4 minus 4ac, so minus 4 times negative 1 times 5 is 20. So negative negative makes that positive, all over 2 times negative 1, which is there. So 2 plus or minus the square root of 24 over negative 2. 24, not a perfect square, not a problem for us though, because we can simplify that. So 2 plus or minus the square root of 4 times 6 over negative 2. 2 plus or minus 2 square root 6 over negative 2. Looking at all three of these numbers that are outside of the radical, we can reduce those. I'm going to divide everything, because this is negative, I'm going to divide everything by negative 2 instead of just the 2. So here's what I'm doing. Divide by negative 2, divide by negative 2, divide by negative 2. So I have negative 1 plus or minus square root of 6 over 1. No one cares about that one. No one cares like if this is 2 divided by 2, it's 1. It's just negative 1 plus or minus square root of 6. And that's it. Okay, you're going to see some stuff that you don't need to see. Okay, now, the discriminant. The discriminant is taken from this formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The discriminant part of it, though, is just the b squared minus 4ac. As far as the discriminant, that's all you care about. And what that does is it tells us how many solutions a quadratic equation has. How many solutions? Later on, we'll talk about what the solutions mean, meaning if you have a graph, actually just talk about it now. If you have a graph, then with regard to the number of solutions, if it is a positive number underneath the square root, then you'll be adding something and then subtracting something like we did for the previous one. So you should have 2 solutions, meaning your graph would touch 2 times. Sorry. Oops. So this would have 2 real solutions. 2 real solutions. If this is 0 underneath here, then it's like having like negative 5 plus or minus the square root of 0. Well, what's the square root of 0? 0. So negative 5 plus or minus 0, that you get the same thing, negative 5. You would only have 1 real solution. And if I were graphing, that means it would touch the x-axis just 1 time. So what would be left? Well, it can touch 2 times, it can touch 1 time, or it could touch not at all. And if that happens, old school would have been for you to say, oh, no solution, this doesn't happen. True, it doesn't happen to where we can see it, but now that we are stepping up our game, we would just say 2 imaginary solutions, excuse me. I'll erase that while I'm at it. 2 imaginary solutions. This is where the I comes in. And we saw it a little bit last week, but we'll see it more in the future. 2 imaginary solutions. That's where you get your I from. Okay, that's not really super duper important. The main thing they want to know from us is, are there 2 real solutions, 1 real solution, or 2 imaginary? So if it's not real, meaning if it's not a positive number or a negative number, then it's automatically, if it's not a positive number or 0, then it's automatically going to be 2 imaginary. So find the discriminant of the quadratic equation and give the number and type of solutions to the given equation. Problem with this one is everything's not on one side. So go ahead and add 5 to both sides. So I have x squared plus 2x plus 5 is equal to 0. And then your a is equal to 1, your b is equal to 2, and your c is equal to 5. You know that you are doing this wrong if it takes you more than like a minute, because you don't want the whole quadratic formula. All you want is the b squared. So that's going to be 2 squared minus 4ac. So this is 4 minus 20, which is negative 16. I don't care that it's 16. It could be any number in the whole wide world. All I care about is that this is negative. So because it's a negative number, which is this situation right here, negative number, this one is when you get a positive number, and this one is when you get just straight 0. Okay, so this is negative, so therefore I have 2 imaginary solutions. 2 imaginary solutions. And that's it. Don't do too much on that one. Okay, number 2, same process as the last one, except the only difference is this one's a little bit easier because everything is already on one side. So your a is 4, b is 4, and your c is 1. So b squared, that's negative 4, excuse me, negative 4 squared minus 4ac. So this is 16 minus 16, which is 0, 0, should be that there's 1 solution. what I like about 0 is 0, 1 real solution. All right, that's it for me. Thanks so much for joining me.